So this is a family of Poncelet triangles inscribed in an ellipse and circumscribing the fixed in circle. So circular caustic, which is the fixed in circle of this family. Um, this family, by definition, will maintain the in-center stationary, the center of the in-circle. But we also find that for specific placement of this caustic, you can also keep the barycenter fixed, the speaker center fixed, and the Nagel point x8 finds stationary point at the center of the outer ellipse, which we thought was pretty cool. As I vary the eccentricity of the outer ellipse, I maintain all these points stationary, and therefore the line that passes through these points is known as the Nagel line, right? So the Nagel line of this family coincides with the minor axis of the outer ellipse. What we can do with this tool further is, for example, let's look at some loci. For example, what's the locus of the circumcenter? There it is. Locus of the circumcenter is an ellipse where one of the foci is x8 or the center of the system. How about the locus of the orthocenter? The orthocenter is up here. That could be studied as well. We know that this ellipse is homothetic to the outer one, to the white one, or a 90-degree rotated copy of the outer one. X5 is also an ellipse, and we know that one of the foci of X5 is the center of the caustic X1. This is always the case, right? Even if I change the eccentricity of the outer one. How about X6? X6 is not an X6 is an ellipse in this case. That's interesting. Normally it is not an ellipse, but here the tool is indicating that X6 is actually traversing an ellipse. This very small thing here. So that's cool. That's unusual. Let's look at X7. X7 is also the Gergon point. So, by the way, X6 is known as a sine median point. X7 is a Gergon point, is also traversing an ellipse, or sweeping an ellipse. X8, as we saw before, is stationary. X9 is also unusual. Sweeping an ellipse. This little E letter here indicates that this locus, this green locus, is numerically an ellipse with this tool. The Feuerbach point is always on the in-circle, so its locus is the in-circle itself. The C here indicates that the locus is circular. Nothing weird here. X12. X13 is not a conic. X14 is not a conic. X15 is not a conic. X16 up here, also not a conic. X17, where's X17? X17 is probably inside, right? So X17 not a conic either. X18, X19, how about X20? X20 is as large, the Longchamp point, right? Related to X4. If I simultaneously display X4 here, I believe the Longchamp is a reflection of X4 with respect to the circumcenter, right? So where is the circumcenter? If I show it here, circumcenter is this moving point with one focus, is an ellipse with one focus on the center of the system, or X8, and you can see here now the orthocenter and the Longchamp point. But the cool thing about this family is that it probably has some interesting invariants. We haven't been able to locate them yet algebraically, but this is a family of Poncelet triangles with a circular caustic that maintain its Nagel line stationary, including the in-center the Nagel point, the barycenter, and the speaker point. Oh yeah, so one last commentary here, or comment, is that if I draw, what is that thing called? Is it called medial triangle? The medial triangle of the outer. Okay, what is the medial triangle? The medial triangle is the triangle that is homothetic to the outer one. It's, I think, quarter size, right? Quarter area and half size. That whose vertices are the midpoints of the outer triangle. Now, the incircle of the medial triangle is known as the speaker circle. Let's draw it. Speaker circle. So here's a speaker circle, or the incircle of the medial triangle. We know that the radius of the speaker circle of the outer is half the in radius, right? So we can see here that the speaker point centered on x10, its center we showed before, is fixed. Its radius is related to the outer in radius by half, so its radius is also going to be conserved. So there you have it. You have system with its medial triangle, its incircle known as the speaker circle, and some geometric stationarities being shown. All right, I'll see you in the next video.